back. This is the video of APRICOT where I'll be discussing one subcommand which I haven't discussed so far. This subcommand is annoscore, which stands for annotation-based scoring. This annotation-based scoring of the predicted domain in our query protein is carried out with respect to the reference domain from CDD or Interpro database. There are four features involved in annotation-based scoring, first being chemical properties, Needleman-Wunsch global alignment score, Euclidean distance of protein compositions, which would be dipeptide and tripeptide composition, and prediction parameter of the predicted sites. Why I haven't explained it so far? Because it uses emboss needle program, so we cannot run it without the complete file system, but now because we have Docker, we have needle, so I can run it now. So just to show you what we require for this, I'm gonna go for -h. So it requires analysis path, which is defined by us, selected data, so it uses only those proteins which have been selected to have domains of our interest, and then it also uses needle directory from the emboss suite, and that was the one which is lacking in cases when we do not install complete file system. So now we should be able to run this. Let's go to our run script. So I'm gonna run the calculate annotation score, and I'm rerunning the format output because I want the output in HTML. So I'm going down to show you how would this work. So here is the call, APRICOT annoscore analysis path and Needleman-Wunsch based analysis by the embossed needle. And then I'm gonna convert it into HTML. So let's run our run script. So this will take some time. However, I've already analyzed it and I have opened the HTML file here. I'm gonna open this up so you can have a look. So this one is the third protein that we introduced. Down the list, we should have also the HFQ protein, which is right here. So what do we get in this? We have protein ID, the UniProt ID, its name, which organism does it come from, how long is the protein, the resources, meaning CDD or Interpro, the ID, domain ID. So as you see, these are not redundant entries, just they have different domains predicted in them. As we go down, we see it. So you can sort it by different protein, different domains. So in our case, we can have what we want. Now the full name, domain length, start, stop, where in protein is it found, and then it extracts the site from our reference sequence, which is the domain, and the site from our query sequence where we have identified domains using the tools inside APRICOT. Then it also gives us the secondary structure. It tells us how much is the coverage. Now we can even see how much is the coverage. Now for example here it's 60%. We can identify identity, similarity, gap. So these are a lot of information. This can be visualized and this can be used by the users in different ways. If you're interested in the first filter, which is coverage by domain length, identity, similarity, and gap, which is basically what we acquire from the prediction, you can use the filter 1. Filter 2 is the chemical properties, where we have used molecular mass, isoelectric point, solubility, van der Waals value, pKa. The third value are our composition, amino acid composition, secondary structure, and physicochemical properties. These two only. Amino acid composition, secondary structure composition. The last one are the composition for physicochemical properties, dipeptide composition, tripeptide composition. At the end, we derive an average filter where you can find the scoring. Now, based on these scoring, you can sort the data set. So these are for filter 1. For filter 2, filter 3, you can sort them, filter 4. So now you can decide which chemical properties or composition or domain prediction out of these features, which is your interest. But at the end, we also have this Bayesian score. So if we look at the Bayesian score, we can identify which protein happened on the top. It's a long list, so you have to go back. So definitely the KH domain containing protein has the high confidence. And not just the protein, but you can also decide which domain you're going to pick. So as you see, you have KH1, NOS KH, PAs KH, and so on. You can choose which domain have the highest coverage and has the highest value from Bayesian scoring. So this was about annoscore. So this is still running. It takes some time because of the usage of needle. However, this is something very important that I wanted to address in different video. For now, that's it. I am gonna look for more ways how I can make the usability of APRICOT more accessible for you. Any question and feedback will be welcome.